Today, for lesson 9, we're looking at solving problems about proportional relationships. And we're going to look at a couple of questions. We're not actually in your handout going to do the back side of today's handout. We're going to save that for tomorrow. Instead, we're going to do a little extra practice with graphs before we move into that. And if you take a look at our goals today, we're going to be solving problems involving proportional relationships. And there's a one here in the table that we're going to start with. And then we want to know that a graph of a proportional relationship lies on a line through point 0, 0. That's the origin of the graph. And we'll talk much more about that as we continue on. So the first activity is looking at a company trying to hire people to read through all the comments on their website to make sure that they're appropriate. 4 people applied for the job and were given 1 day to show how quickly they could check comments, because speed would be important in a job like this. We're going to need to write an equation or a table to help us compare these 4 employees, these 4 candidates, to see who is going to be the best choice for employment. So first, we're going to look at person 1. And it tells us person 1 worked for 210 minutes and checked a total of 50,000 comments. Now, using that information, we're going to find 2 things, and this is going to be the same 2 things for each of the 4 candidates. First, we're going to know how many total comments they checked. But if you look closely at each person worked for a different amount of time. So finding the total amount of comments checked is not necessarily the fairest way to compare these 4 employees. If we look at the number of comments per minute, then we're finding a comparison between these 4 employees that is a fair way of checking this, so that in 1 minute's time, how many comments did that person get through? That would be their speed in checking these comments. So let's start with the total. If we look at person 1 and we're told 210 minutes passed and 50,000 comments. Now, we could look at that with a table and we would be comparing the time to the comments. So 210 minutes, 50,000 comments. That'd be one way to look at it. Now, really, that's not necessary. I really need to be creating a ratio that I can turn into a unit rate. So I want to know in 1 minute's time, so I'm going to put the minutes here on the bottom, how many comments can be checked. I don't want to do it the other way around, or what I'm going to find is how much time it takes per comment. And that's going to be just a fraction of a minute. If they're checking 50,000 comments in 210 minutes, then 1 comment is going to take just a part of a minute to check, a very small part. And that's not what we're comparing them by. We're comparing how many comments in 1 minute per minute. So this ratio can be divided. Remember, I can divide 50,000 by 210, and that would tell me, first my total comments would be 50,000. But when I divide that to get my unit rate, also my constant of proportionality, that's going to be 238.09 comments every minute. All right. Next, we're told that person 2 took 200 minutes. They checked a total of 1,325 comments every 5 minutes. Now, that is adding a little bit of complication to this. So every 5 minutes, this is what was checked. Now we need to change that into a ratio for 200 minutes. This would be a good time to set up a proportion. If I were to write the ratio that we're given, 1,325 comments in 5 minutes. So comments and minutes, and this could be done in a table too, of course, but just another way of looking at it here. I could look here at 200 minutes, and if you remember back when we were talking more about scaled copies, we were looking at how these ratios are compared to one another, making a proportion. So 5 times what would give me 200, and I'm going to use that same multiplier to change the amount of comments. So it would be 40 times 40 to get 200 minutes. So I would do the same here as well, 1,325 comments times 40, and that would give me a total number of comments of 53,000. So that's my total. And the number of comments per minute now honestly, I could use either ratio to find this. I could divide 1,325 by 5 or 53,000 by 200 because they are both equivalent. And this is a constant speed that we're finding. So either is going to give me the same unit rate, and that unit rate would be 265 comments every minute. All right, let's continue. We're going to look at person 3. It says they worked 120 minutes, a rate represented by the equation here, where C is the number of comments checked and T is the amount of time. Now, just by looking at that equation, I can see my constant of proportionality. My K value is 331. That answers one of my questions right here. So the number of comments in 1 minute is the constant of proportionality, 331 comments. Now I do need to calculate the total, so I'm going to have to use this equation to find the number of total comments, multiplying the constant of proportionality by the number of minutes, 120 minutes. And that would give me a total of 39,720. All right, let's look at the last one. Person 4 worked for 150 minutes at a rate represented by T equals 3/800ths times C. Now notice, going from the first equation that we worked with person 3 to the equation here, these variables have changed places. Now this equation finds the total amount of time, and this is using the number of comments. So here for person 4, we're only given a time. That time of 150 minutes is going to go here in the equation. So let me rewrite that equation. 150 equals 3/800ths times C. Now C is what I don't know and also what I'm trying to find. So let's think about this for a second. This is also a constant of proportionality, but because the variables have switched places, what this constant of proportionality is telling me is the time it took to check one comment, not how many comments could be checked in 1 minute. So if I were to use that here as the number of comments for 1 minute, then I should be able to use the reciprocal of my constant of proportionality here, which would be 800 over 3. 800 divided by 3 is going to give me a repeating decimal, but I do want it, I don't want to put 800 over 3 because that's going to be hard to compare to the other 3 employees. So I will divide it. 800 divided by 3 is 266.6 repeating. I only need that one digit with the repeating symbol to show that. All right. And really, when we start comparing, I don't think this decimal amount is going to be important anyways. If we had rounded to the nearest whole number, that probably would have been fine. Then let's find the total number of comments. That's this variable here that we don't know. So we're going to have to use this equation to find it. All right, I can use this new constant of proportionality that I found from the one that was given in the equation, or I can use the equation. Remember, we can go back and forth in an equation just like we can in a table. So instead of multiplying something times this constant of proportionality, I'm going to divide by 3 over 800, or I could do some multiplication. Either one is going to work. I'm just going to have to multiply by this reciprocal, this new constant of proportionality. So I like divide. Let's do 150 divided by the constant of proportionality. That's going to send us backwards in that table. And what you would get for the total number of comments is 40,000 comments. All right, now we have all that information to compare. If we were the hiring person at this company, we want someone fast, we want the most efficient person to hire for the job. And the first question there says, order the people from greatest to least in terms of comments checked. That's the total number of comments. So we're going to look at our answer to this first question. We can see person 2 completed the most total comments, while person 3 had the fewest. So let's go ahead and order those here. We have for the greatest, that'd be person 2, then 1, then 4, and finally 3 would be the least. Secondly, though, it wants us to order the people from greatest to least in terms of how fast they check the comments. That's their speed, and that comes from the unit rate that we found for each one. How many comments did they check per minute? So if we go back to our information, we're looking now at the second calculation that we found, and you can see that person 3 checked the most comments each minute, while person 1 checked the least. So let's go ahead and do that. That would go in the order of 3, 4, 2, and 1. Now we'd have to make a decision there on who's going to be the better hire for the job, but this here is probably going to be the better way to compare those employees, knowing that they are checking more comments per minute, not necessarily looking at the total comments they checked, because it's not really a fair way to compare them. All right, we've got one more question here on this side of the handout that we're going to do today, and it's talking about steel beams. A steel beam can be cut to different lengths for a project. Assuming the weight of a steel beam is proportional to its length, what information would you need to know to write an equation that represents this relationship? I'm going to start by thinking about a table. So we're comparing two things. We're comparing the weight to the length. Now, that's as far as I can go with this. I don't have any other information, and it's wanting me to write an equation. What information would I need to know to write that equation? Well, if you remember our format, our pattern for this equation for a proportional relationship, y equals k times x, I always start by finding that k value, that constant of proportionality. So I would need to know a ratio to find it, wouldn't I? I would need to know the weight of a specific length of this steel beam. Now, if it was a unit rate, that would be way easier, because then I would know if and I would have to make up a measurement because I'm not even told that, but let's say 1 kilogram of the steel beam, whatever its length is, that's going to tell me the constant of proportionality right away, being a unit rate, because I would have 1 to an amount, 1 being compared to an amount. If that wasn't the case, if I was given another ratio, that's okay too. All I need to do is divide this value by the weight, divide the length of the beam by the weight, and I would know that constant of proportionality to create my equation. Now, let's talk about what you're going to work on next. So if you turn the page in your packet, you should see a handout titled Examining Graphs, and it begins with a graph that looks like this. This is what we're going to do today. We're going to do the front and the back of this just as some extra practice with graphs as we continue looking at these with proportional relationships. All right, so a couple of reminders, important reminders, is first in a graph, pay very close attention to how each axis is labeled. So here we have hours and we have distance in miles. Now please remember that this is the x-axis and this is the y-axis. And that's going to become very important when you start looking at the answer choices on this handout, because it's going to give you different points on that graph that will have two numbers. Now, the first number in this ordered pair is always going to be the x value. So whatever that number is, we would find it here along the x-axis. And then our second number is our y value, and we would follow that up vertically up the y-axis. So let's say that my point was 2 and 16. All right. I would go starting here at the origin. Remember, this is the origin, that 0, 0 point that all of our lines of proportional relationships start from. I would go on the x-axis out to 2, and then I would move up vertically until I got to 16, and it would be this point here on the graph. Now, if you reverse that, you get an entirely different location. So if I did that backwards and I went to 16 on the x-axis, here you can see I can't even go to 16 because the numbers don't allow it. We would be way out past the graph and only up 2, which would be nowhere near a point here on this line. All right? So pay close attention to the labels. I would suggest for each graph, go ahead and just put a little X and Y so that you can keep that straight. And please make sure you write this down so you remember the order of what numbers represent the X value and the Y value on that axis. All right. Don't forget that you can use any point along this line to answer your question. So this point here that I had, which was 2 on the x-axis, 16 on the y-axis, can tell me the unit rate. If we think of it in a table, we're used to seeing x and y values in a table like this, right? So I could get the unit rate by dividing 16 by 2. That would give me 1 and 8. And look here, if I go to 1 and then up to 8, that is another point on my line of my proportional relationship. That should tell you that any point along this line will be proportional to the others and could fill in to a graph or a table, just like what we've been working with previously. So I do want you to do both sides of this activity, please. I'll be on Zoom to answer questions and adding some of the answers onto this Edpuzzle. And tomorrow we will continue with the back side of the handout on lesson 10 with a little more practice to follow. Everybody have a great day.